Hi, everybody. Welcome. Thanks for potentially making your significant others upset and coming to class tonight. You all are my Valentine this year. And if my wife is watching this video, that's a lie. It's you, honey, I promise. I love you. Okay. I don't think I really have many reminders, except for, it's almost Sunday, and you know what that means. We got more assignments due on Sunday. So if you finish the studio today, you can try to get a jump start on those assignments, possibly. Or, I don't know, maybe some of you are going to run out of here and try and grab a table somewhere, I don't know. But either way, those assignments are due on Sunday. And we're just going to keep chugging right along. Are there any questions for me before we begin on the material for today? No? All right, cool. Let's hop right in then. So we introduced a second kind of loop in this prep work called a while loop. Before we've been using for loops. What's the difference? Or there might be more than one difference.
For loop is definite.
For loop is definite. Oh, okay. I like that answer. Yeah. How does it look different in the code? If I'm coding up the two loops, what's going to look different style-wise? What does a while loop need to do its job, I guess? A condition, right? It needs an expression that evaluates to be what type? True or false, which is a Boolean. Yeah, Boolean. So while loop needs a Boolean expression to run, whereas a for loop just needs a set of values, right? A list of values would be a better way of saying it in Python. And so this is an important question. When should I choose to use a while loop versus a for loop? Somebody already sort of pushed me in the right direction on this answer. Can we follow up on that a little bit? When should I choose to use a while loop over a for loop, or vice versa? Yeah, go ahead.
You'd want to use a for loop if you have a definite amount of input to process. So
Okay.
like what we're doing so far when we have like 3 or 4 test scores.
Yeah.
Then you'd want to use a for.
So if I know exactly how many times I want that loop to run, that's a good time for a for loop. Could I use a while loop? Yeah, sure, absolutely. I could use a while loop for that purpose too. In fact, some programmers like while loops a lot, and they'll just default to using while loops for things, even if they could use a for loop. Other people are the opposite. They're going to try to use a for loop unless they absolutely cannot use one, which would happen when I don't necessarily know how many times that loop needs to run to complete its task. It should be noted too, when we say that for loops know how many times they're going to run, right? We may not be able to look at a for loop and say that's going to run 7 times. By knowing how many times it's going to run, that can be variable, right? We could say it's going to run X number of times. That's still definite in our considerations. So what's a good case for a while loop? I know the textbook presented a problem that used a while loop to do processing even and odd numbers for various things. What's another good place where you might expect to see a while loop being used? Process a file that changes a lot. So what would the while loop be used for in that situation? Okay. Yeah, you don't know how long the file is. You don't know how much stuff's in there. Okay. Any other situations? Yeah. Yeah, user input's the classic example for a while loop. We don't know what people are going to type into your program. We hope that they get it right the first time. And so do they, probably, right? But the fact is that sometimes they're going to give you bad input. Your program's going to get bad input. And how many times you're going to get bad input? I don't know. Hopefully 0, but it could be an infinite amount, right? Somebody could literally sit there for their entire life and just type in garbage. I think that's a little unrealistic, but theoretically it's possible. And we could sit there and just wait forever until they type in a value that works. And so we need to be able to accommodate that kind of situation. In fact, that pattern is so common that it has a name. It's called a Sentinel Pattern. I'm going to write a while loop that sits there and asks for input. It stands guard on your input until you get input that is going to work, valid input from your user. It's a pretty common pattern. We're going to see it pop up from time to time as we progress through the course. What does a break statement do?
Takes you out of the loop.
It gets you out of there. It gets you out of the loop. Does it work with both kinds of loops? For loops and while loops? It sure does. Yeah, it sure does. So if you ever need to abort a loop, a break statement will get you out of there. Now, that being said, I don't think break statements are very common. If you see yourself using break statements all over the place, that's an indication that maybe you should do a better job of thinking about the bounds of your loops and specifying the loop conditions a little bit more clearly. You're welcome to use break statements. I'm not saying you should never use them, but they should not be used as an excuse to write sloppy loop conditions and then bail yourself out, I guess is the point I'm trying to make here. What does a continue statement do? It goes to the next iteration. So this is useful if, so oftentimes when I see a continue statement, it's going to be at the beginning or the middle, perhaps, of an iteration. It's going to skip whatever comes after it and just go directly to the next iteration. I think these are even less common than break statements. I really do not see continue statements very often at all. I do see break statements, though, from time to time. It's good to be aware of them. What's an escape character? I think we've already talked about this a little bit, or I've definitely talked to some people about this at least. What's an escape character? Tab. So that's an example. What else? Return. So like a new line. Any others you can think of?
Space.
Those are the big ones. Tab, new line are the ones that you're probably going to see most often. Space. There might be an escape character for space. I'm not sure if there is actually. There's a lot of them though. In fact, well, a lot might be a stretch. There are a handful of them. Escape characters. All right, good old Wikipedia. Here we go. New line, tab, backspace, that's an interesting one. And then you see these single quotes, double quotes, backslash. So there's a pattern here, right? I know it's an escape character if I'm looking at it and I see a slash. That backslash out in front. That's the indication that I'm talking about an escape character. We use these for things that can't be typed directly into your code. Can't be typed directly into a string. How do I type a tab into a string? I don't know. I can hit the tab key, but that may not actually work the way I'm expecting it to, right? It may not actually show that tab on the screen. If I type /t, you're telling the computer I want to put a tab here. Same thing for a new line. If I'm typing a bunch of code and I put in a new line in the middle of a string, what's going to happen?
Print a new line. Use the print thing.
It'll print it on the same line. It's not going to print the new line. If I actually hit return and moved my code down to the next line, right? It doesn't print the new line. It just treats it all as the same line. If I really want to go to a new line, the way to do that is /n.
I don't know if you're asking about the slash. Sorry.
Yeah, well, I was trying to make the difference between /n versus just hitting return on your keyboard, right? There's a difference between the two. So those are the two most common. New line and tab are the two most common ones you're going to see. You might see single quote, double quote, and backslash occasionally as well. Backslash is, I don't know, I think backslash is the most interesting one. If I want to put a backslash in a string, I have to hit backslash, backslash. And that's because when the computer sees the first backslash, it thinks that you might put an N or a T or something else like that after it. It doesn't think that you're actually using a backslash. So you have to put the second backslash there to tell the computer, no, I'm very serious. I want a backslash here. So just something to keep in mind. I know this says JavaScript, but these actually worked across many different languages. They're not unique to JavaScript. All right, let me get back to my slides here. Are there any questions so far before we hop to the next slide? Any questions? Alrighty. Let's talk about images. So if I look at an image, right, and what's the structure of that image? How is that image set up? Looks like what? Pixels. All right, it's made up of a lot of pixels, right? And how are those pixels situated within the image? Rows and columns. Rows and columns. It's a grid. Where's the grid start? Top left. Top left. Which is, I don't know how you guys feel about that, but first time I heard about that, it was very annoying. Because from algebra class back in the day, 0, 0 wasn't in the top left, it was in the middle. Or, I mean, it'd be like at the bottom left corner of our monitor would be the place to put it if you were thinking about it from math class. But, you know, it didn't end up that way. And there's actually a good reason for that. They are making you view the image like you're reading a book, starting at the top left corner and reading left to right down the image. So who decided that? I don't know. Some old guy a few decades ago decided that, and now we're stuck with it. That happens a lot. But that's the structure of an image. I have a two-dimensional grid, right, of pixels. So what's in a pixel? How do I define a color?
Red, green, and blue.
Red, green, and blue.
And then the number associated with it, anywhere from 0 to 255.
Yeah, so those values all can go from 0 to 255, and the combination of red, green, and blue, I can get any color that I want. Well, I mean, that's a little bit of an exaggeration, I suppose, but I can get a lot of different colors that way. I can get the whole rainbow doing things that way. Okay, so if I give you an image and I say, hey, I want you to process this image somehow. We're actually going to take a look at an exercise shortly to apply a red filter to an image. What structure am I going to expect to see if I ask you to process an image? What coding structure? What tools from our toolbox are you going to use to make sure that you actually process every single piece, every single pixel in that image? A for loop? Just one? 2 for loops, nested for loops, right? I've got one for the rows and one for the columns. I think that's important too. In fact, this is a point that I'm going to probably stress multiple times as we go through. If I write a for loop, I really want to be able to explain what that for loop is for in English. This for loop is for the rows of my image. This for loop is for the columns of my image. I think it's very important to be able to explain that to yourself. Writing a for loop just for the heck of writing a for loop could potentially get you into some trouble. So make sure you understand what each actual loop is for. We actually saw an example of nested for loops, was it last time? Or it was recently that we did a little example with nested for loops. We're going to start to see them a lot more, especially as we're working with images. And then last, but certainly not least, if I want to manipulate an image, what are some useful methods that I can use to help me? What are some methods that you saw being used to manipulate images in the prep work today? Get pixel, that's a good one. So I grab the pixel and then what can I use then to get more information out of a pixel? I'm sorry? Get color? I think it's like get red, get green, get blue. So I can get each of the 3 components, right? I can make new pixels. I can specify what each of those 3 components are and make new colors that way if I want to. In fact, the book put a list of things. There's actually 2 lists on this page. There's one up here for the pixels themselves. You see get red, get green, get blue, and then the opposite. Set red, set green, set blue, so I can manipulate the values. This is a pretty common setup, right? The gets are for reading the values that exist, whereas the sets are for changing the values to something different, manipulating those values, or reading versus writing. It's a pretty common way of approaching an object in many programming languages. And then if we scroll down here, there's a whole nother list for images. So I can make an empty image. I can get the size of an image, which is important for what we were just talking about. If I need to write a loop. If I want to loop over the rows and the columns, I need to know how many rows and columns I have. Question?
Are those all within the same? Are those all within the image class?
So these are within the image class. Yes, you can see it's actually referencing the image module here. And then this IMG is an image object. So yes, it's part of the image class.
Also the color ones?
The color ones, if I go up here, these are actually part of the pixel object. So P here is a pixel, not an image. And that's an important distinction to make. Yeah, it's a very important distinction to make.
And that could be named anything other than P.
It could be named anything, yeah. It does not have to be called P, that's correct. In fact, we're going to see examples of that when we do the walkthrough here in a few minutes. Yeah, we can call this whatever we want, but it has to be a pixel. It has to be a pixel.
How do you name the pixel?
How do you name the pixel? I create a variable for it, and I, just like any other variable, call it whatever.
Is any variable with 3 numbers between?
Here we go.
Is any list with 3 numbers between 0 and 255 a pixel?
No. I can't just have an arbitrary list with numbers in the right range and call it a pixel. I have to create a pixel I actually have to use the word pixel. Here's an example. This doesn't save it to a variable, but I could say P equals this, and then I would have a pixel with those values, those attributes. This is getting a little bit ahead of where we are, but this is called a constructor. It makes a new pixel object. It constructs a new pixel object. We'll actually talk a lot about constructors when we get to objects in just a couple of weeks, actually. We're getting very close. And then this is an image constructor. Actually, this is also an image constructor. They're both image constructors. This one opens an already existing image, and this one just creates an empty image, a blank image that we can then manipulate. So they both create image objects that we can then use these methods on. So as programmers, stuff like this, these lists of methods, these lists of behaviors is invaluable. I mean, we need this to do our job. And part of your job as a programmer is understanding, okay, I'm doing image manipulation. I should go out there and see what kinds of behaviors, what kinds of methods are available for me to interact with these images, to interact with these pixels in order to do my job. Honestly, there's probably more than this that are available. This is just the list of things that we need in the scope of the class. But there's probably a lot more out there. This is an example of what I would call an API, an application programming interface. Basically, if I want to use an image, what are the tools, what are the methods that I can use to interact with that image? It's very useful. Yes?
Did you get to the bottom one? What's MP mean?
MP? Where?
The very last member of the list. Pixel.
Oh, set the pixel at column row 50 to be MP. This is just a pixel.
Okay, that's just a variable.
Yep, just a variable. That's right.
Wait, but how would it already has a, okay, yes, I get it.
Just a variable.
Yep.
Any other questions? Great questions. Any other questions? Manipulating images is fun because you can actually see the work that you're doing directly on the image, so it's a lot of fun. If there aren't any questions, we can hop on ahead to the walkthrough for today. That's the studio. We'll talk about that in a moment. What we want to do is the walkthrough, and we're going to write a program. I left a little bit of stuff for us, the imports, loading the image. We want to apply a red filter to this image. So to apply a red filter, the idea is I'm going to look at the pixels in this image. I'm going to keep whatever the red value is. Whatever the green value and the blue values are, I'm just going to throw those out. I'm going to set them to 0. I'm going to remove them, basically. So what I'm left with is only the red component of every single pixel in this image. Does that make sense? I'm keeping the red values and I'm getting rid of the other values of this image. So I want to pseudocode this first. I want to walk through this problem in English first, and then we'll figure out how to come back and code it up properly. So help me out here. I want to take this image here, right, and apply a red filter to it. I want to grab all the red information out of the pixels and throw everything else out. So what am I going to need? What kinds of things do you expect I might need to pull this off? What do you think I'm going to need to do in English to pull this off? We're going to need to go pixel by pixel. So how do we do that?
You need to know how many columns and how
I need to know how many columns and how many rows, right? So for every column in the image, this is our nested for loop, right? And then for every, wait, am I doing this right? Yeah. Should we do rows first?
I think it's,
Does it matter? That's a good question. Does it matter if I do rows or columns first? I heard yes and no.
well, I heard it up in the chart, I think they always did row column.
They always did row column. Yeah, that's a good question. I mean, so there's actually multiple questions here. The first question that I just asked was, does it matter if I do rows first or columns first? The answer to that question is no. I can still get the same answer if I do columns first or rows first. But there's another question, which is, you know, which way makes the most sense? Which way feels the right way to do things? And by feels the right way, there's a couple ways we could measure that. What have we seen in previous examples is one way. What is the rest of the world doing, right? Or what just feels the most natural to us? The most natural to us is to treat the image like a book. Start at the top corner and go across, and then go across, and then go across, and then go across. So that kind of behavior is defined how? How is that behavior defined? If I want to read it like a book. Row first and then column. Row first and then column. In fact, this is a very, 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 very common way of approaching any kind of two-dimensional structure. Go down the rows first and then down the columns. Can you swap the two? Yes, absolutely. And there might even be situations where you would want to do that, right? That might actually be something that's necessary to solve a particular problem. This particular problem, it does not matter. For this particular problem, it does not make a difference. And I can prove it to you when we write the code. I can swap the two, and we can see that it actually won't make a difference on our final result. But for other situations, it very well could matter. We'll stick with the standard. All right, so how does this work? I've got my loop. So inside this loop, I know that I'm going to visit every single pixel, right? Every single pixel in the image. So what do I want to do then? What's the next step? Yeah, in the back.
Maybe perhaps before, try to grab the width and the height.
The width and the height? I mean, sure. No, like we could make variables for that if we want to, sure. Create variables for width and height of image. Sure, that's fine. Any other suggestions? Any others? We got to adjust the color somehow. So that's, you know, that's actually a hefty chunk of work. Can we try to break that down into smaller pieces? You're absolutely right, but can we break it down into smaller chunks? So I have to grab a pixel first. I have to grab a pixel out of the image first, right? So grab pixel. Which pixel am I going to get? Whichever row and column I'm currently at, right? At current row and column. So I'm going to grab that pixel, whichever pixel is in my current row and column. So I'll get that pixel. Then what am I going to do? Which color am I interested in? Red. All right. Grab the red value out of that pixel. All right. Then what? Adjust it. I'm actually not changing the red value. It's actually the other two values that I'm changing. Right? I'm throwing out the green and the blue. I'm keeping the red and tossing everything else. I can make a new pixel. I can make a new pixel. Make a new pixel with the red value. What should the blue and green values be then? Blue and green are 0. Okay? see if I can scroll down a little bit. Question?
Yeah, what's the difference functionally between setting the values of those to 0 and setting them to 255?
Well, if I set them to 255, I'm saying I want green to be maxed out. I want to see green all the way. So if I turn every single color up to 255, what do I get? White? Black? Do we know? Do we need to have a an arm wrestle about it or something?
0, 0, 0.
All right.
Oh.
Let's ask the Google, right? RGB values. I hear somebody sounding very confident in the back. Black is 0, 0, 0. Black is 0, 0, 0. Well, that's weird. Yeah, I don't disagree with you. Black is the absence of color. That's correct. White is the presence of all colors. Yeah. There's your physics lesson for the day. So by setting it to zeros, we're removing those from the pixel entirely. If we cranked them up, we would see, well, we could try it later actually and see what we would see. I guess we would see a lighter version of the color would be my guess. I'm not entirely sure. I was never great at art class, so we'll just experiment.
So if red's a really dark, a 255 red is a really dark color, then as you're moving the number up, it should be like a
Yeah, if we had a really red pixel to begin with and we cranked these up, then it would get whiter, right? It would get closer to white. If we had a pixel that wasn't very red and we cranked these up, it would be green and blue make what? Purple? I don't know. Cyan? I don't know this stuff, you guys. I really don't. It makes a color. Yeah.
It's just like, it's confusing to me because like if you took like paint and you had red, green, and blue paint, you smeared them all together,
Sure.
it would get darker and darker.
That's true.
So it's like,
You would get, yeah. And well, that's the other thing too. RGB is not the primary colors, right? That's not what people traditionally think of when they are mixing colors together. Like is it yellow that's the other primary? So what the heck's green doing in here? I don't know. They didn't ask me. They shouldn't have asked me because I wouldn't know what to do anyway. I'm terrible at colors.
It has to do with light.
Yeah. Well, so the reason that they picked RGB has more to do with how well the computer can display those colors. Actually, I don't recommend that you do this. So please, if you go blind, it's not my fault. If you put your face like right up to a screen, what is a pixel actually made out of? It's got a little red component, a little green component, and a little blue component. And so when you specify RGB values, you are literally saying, I want this little piece of 3 lights on my computer to have these intensities. And that's how you get colors. That's how your computer screen works at a very high level, right? And so the reason that we have RGB has to do with the fact that it's very easy for us to manufacture and see those colors on a computer screen, basically. That's why we ended up with this system. Not having anything to do with art. No artists were consulted at any point in time when this system was developed. I'm pretty sure. I wasn't there. So yeah. Let's get back to this problem. That was a fun thing, though. So we're going to make this new pixel. What are we going to do with it? What are we going to do with it? We already did that. Make this new pixel with the red value that we got. Blue and green are 0. So we're going to set blue and green to 0. We want to get them out of there. So we have our pixel. This is the pixel that we want. What am I going to do with it? Where's it going to go? Back in the same spot? All right, whoops. This lamp is driving me crazy. Sorry. Put the pixel back where, put the new pixel in, right? Put the new pixel into current row and column.
Why can't we change the color of the existing pixel?
Well, that's a good question. Maybe we can. Maybe we can. I don't see any reason why we couldn't. Just call set red, sure. We could try it.
Or not even, we don't even have to fuss with red at all, right? We could just set.
Or not red, yeah, I'm sorry.
Blue, 0,
Green and blue. Green and blue, yeah. Set green and blue.
red alone.
Yeah, we could try it. I kind of like doing it this way because even though it might be a little bit longer, I think it's just good for explaining the process a little bit more. I actually think that there are some people out there. There might even be some people in this room who are like very focused on writing code that is as short as humanly possible, and I can understand that, right? There's a certain value to that. But if your code is so short as to make it unintelligible, I think that's a detriment. I think sometimes it's worth it to take a little extra time and explain it out in long form so that it's more clear what's going on in your code. Especially as an instructor, it's just second nature for me to kind of take the long road sometimes to explain stuff. Get a little bit more of a bigger picture about what's going on. So I'm going to stick with this, but we're going to have some time. We can play around with this and see what other implementations may or may not work and create some weird pictures, hopefully. Are we done? Are we ready to start writing some actual code? No? What are we missing? I gotta put the picture on the screen. How do I? So I'll just type it in English. We'll figure out how to do that later. Put the image on the screen. All right. Oh, on the screen. On the screen. All right. Are we ready to start writing some code now? I think we are. I want to write some code. I'm itching to write some code. We might have forgotten something. That's okay. We'll figure it out. Right? I don't expect to get this right the first time. I expect to screw it up the first time, and then we'll figure out what went wrong and hopefully get to the right answer. So let's get started. We're going to create some variables for the width and the height of the image. It seems like width and height would be great variable names. And I think, I pulled this up for a reason, right? I pulled this up to have it handy so that I could reference it as I'm walking through and figure out, what I need to do. Here, this looks perfect. In fact, I could almost just steal this line of code and paste it in. I'm not going to do that. I'm going to type it out. But that looks perfect. Image.getWidth. And then I'll make the height. Image.getHeight. Okay. Now I got to write these for loops. For. We always use I. That's a pretty typical loop variable. I in what? Range. So for every row, the rows tell me, which variable am I going to use here? The height. And then another for loop that does the same thing. And then, we just keep going up the alphabet. So for J is common. Or if that bothers you, this is totally fine. Row. Column. That's fine if it makes it a little bit more clear what's going on. This is totally fine. In fact, I'll leave it like this. In range width. Okay. There's our loops. Our next comment here says to grab the pixel at the current row and column. So how do I do that? Well, let's look it up. Oh, here we go. Get pixel. Now be careful. Column first. And then the row, so we have to be a little bit careful. That's why it might have been good for us to change those loop variables to say row and column so that we know exactly which ones we're using. So column first and then row to get the pixel. All right. Image.getPixel column first and then row. Are we good? Stick it in a variable. That's a great idea. Pixel. Okay. Do they need to be switched? So if I look at a grid and it's got 10 rows, that tells me top to bottom, right? If I look at a grid and it's got 5 columns, that tells me how big it is left to right, right? I'm still making the claim that we could switch these two, and so we'll come back and revisit that later. But right now we're on a moving train, so let's keep it rolling. I'm going to grab the red value out of this pixel, and I'm going to keep doing what I've been doing. I'm going to go back to the list, find something that looks like it's going to help me out. I'm sure you probably already have an idea anyway, but this is what programming is, right? Find something on the list that I think might help me perform this task. Am I going the wrong way? I'm going the wrong way. Should have gone. There it is. Get red. All right. Red equals pixel dot get red. Okay. We're getting there. I'm going to make a new pixel with the red value blue. I'm sorry, with the red value and blue and green. And that statement needs a little work, doesn't it? With the red value. I don't know how to say this.
Well, actually, at this point, you've already got your red.
I've already got my red.
Set your blue and your green to 0 at this point.
I mean, I was just being nitpicky about my grammar, but I'm a computer programmer, so whatever,
Oh, okay.
doesn't matter. Thanks. That makes a lot of sense. Thank you. All right, let's make a new pixel. Again, how do I do that? Well, let's take a look. Here we go. Pixel. And we see that it goes RGB, right? So if I want to make a new pixel with this red value and blue and green are 0, I say pixel red 0, 0. But I want to probably save this, right? New pixel. And we're almost done. Just a couple things left on our list. We're going to put this new pixel into the current row and column. So image dot, what was it? Put pixel? Set pixel. Set pixel. Column, row, pixel. All right? Set pixel. Column, row, new pixel. Oops. Okay, and then we have to put the image on the screen. And I'll be honest with you guys, I don't remember how to do this. I have to look it up. Not ashamed. In fact, I could probably just find one of these examples up here, maybe. They would do it for me. Or not. Oh, I went the wrong way. Oh, they just did it. Oh, they're just using print. Where are they actually showing the image, though? Here we go. This will work. Image.draw win. What's win, though? Oh, it's the window. So I have to do this first, right? I have to make an image window. I have to draw the image, and then exit on click. Well, let's just copy this. I don't have it already, right? No, I do not. So I have to make the image window. So we forgot something. We kind of forgot something, right? Make the image window. All right. Then I'll say image.draw win, and then it's win.exit on click. Did I type that right? Let's see. Let's double check. Oh, no, it's all lowercase. Okay. My fault. All right. Is this going to work? I honestly don't know, but I feel like we're at a point where we can at least try it out and see where we're at. And if we have to make some changes, we certainly will. So here we go, moment of truth. Let's slap this run button. And oh, I have an error. Pixel is not defined on line 20.
Should it be a lowercase p?
Lowercase p. Is that what the documentation says? Pixel dot pixel. Ah.
Lowercase pixel dot uppercase.
Image dot image. Oh. So here it does say capital pixel, but clearly it's not working, right? Image sys. All right. I'm sorry? That would make the entire picture red. Like just a bright block of red, which is not what I want. I want to apply a red filter to the image. So I still want to see the picture, I just want that picture to be red. Do I have to import pixel? We can try it. Boom, run. No module named pixel. Nope. Pixel comes from the image module. I mean, I'm sure there's an example. Here we go. Here we go. Image.pixel. So it's in the image module. So what happened? The documentation was not complete. This happens all the time, right? The people that write this stuff are only humans. The people that write this stuff someday is going to be you. And you're going to forget to put something in the documentation too. It happens all the time. It happens all the time. Thankfully, we have some other examples, some other sources that we can use to help us figure it out. Image.pixel. All right, let's give it another go. Now that we fixed that, oh, okay, this is a little promising because it does take a little while for it to process, right? So the fact that it's froze on me is not too concerning. Hey. Yeah, I know it's not the greatest thing to see on this screen, but it is the picture, I promise you. You can see the bell, you can see Luther College, and it's just very red now. Very, very red. And so when I see really dark pixels, like this almost looks black in here, that means that the red content was very low. It was very low on those pixels, so it's close to 000. And when I see the lighter pixels, the lighter red, that means the red content was very high on those. And then, of course, anywhere in between. We had a couple other things we wanted to mess around with, but before that happens, does anybody have any questions about this solution that we've got? This is a solution. You may have already noticed that it's not the solution that was here in the first place, but it is a solution to this problem. Anybody have any questions? So we wanted to test a couple things, like could I switch the rows and the columns in these loops, and would it actually get me the same place? I'm claiming the answer is yes, but you don't just have to take my word for it. We can flip them and see.
Doesn't it change the way it does the filter?
Yeah, so I mean, this obviously is doing something, right? It's not going to have no effect. But let's just make sure that it still works. So how's it going to change? Instead of going left to right like a book, it's like I'm reading in Japanese, right? I'm going down instead, going down. But it ends up the same result. I'm still pulling out the red values and putting them back. So the order that I process the pixels in this case actually doesn't really matter. In this case. In other situations, in fact, well, actually, today's studio I feel like is similar in that regard, but there are problems in which it certainly would make a difference whether you do rows or columns first. But I'll put it back just because having rows first and then columns is a pretty standard way of coding this up. Somebody else was asking if we could just set the colors directly in the pixels, like maybe we took too many steps here. We can test that too. In fact, I think if we were being really ambitious, we might be able to, could we do this all in one line? I feel like we could condense these 4 lines of code down to at least 2 lines, if not 1. It would be a very long line of code though, which is another reason why I like just being more explicit about it and doing it this way. I don't have to say get red. I could just say set green to 0, right? And then pixel.set blue to 0. And then I would just pass in so this line I don't need anymore. Something like this. Is this kind of what you had in mind? Set green to 0, set blue to 0, and then just put the pixel back. Grab the pixel, change green and blue, put it back. Let's try it. Takes a while. Oh.
Oh, that's a different color.
It works. It works. All right, found another way to do it. Great. That's awesome. Yeah. Can I click on the what? The window? I mean, I can. It doesn't do anything. Are you talking about this one here? Exit on click? Yeah, this would make a difference if we were not in the textbook. Having the textbook on the website like this actually changes things pretty significantly. If this was an actual program, right, it would pop a window up on your computer, and then when you clicked on it, the window would disappear. But this is a website, so if I clicked this and my whole browser shut down, I'd be pretty unhappy about that. So they altered the way that that works so that that doesn't happen. It's still good practice, though. Yeah. Great observation. Any other questions about this example? Any other questions? You're going to do more image manipulation in the studio today. You're going to make blurry images, which is kind of fun. We're also going to do something a little bit different today. Some of you, I think, have already been doing a little bit of this, but we're going to ask that everybody do a little bit of paired programming today. So your TAs are going to, I don't know if they're going to pair you up or just ask you to make your own pairs, but we do want you to work in pairs today. Your TAs are going to help facilitate that process when you break up into groups. I will go over the studio as usual around 8 o'clock. And if you finish the studio up, keep working on the assignments or start on the prep work for next week. Let me know if you have any questions. I'll be around.